In the early 20th century, the world was plagued by deadly infectious diseases, such as smallpox, malaria, and pneumonia. But little did anyone know that a small, seemingly insignificant mold would change medical history.
It all began in 1928 when Scottish scientist Alexander Fleming made a remarkable discovery. Fleming was working at St. Mary's Hospital in London when he noticed something unusual. A petri dish holding Staphylococcus bacteria had been left while he was on a holiday, and a mold called Penicillium had accidentally contaminated the bacteria.
Fleming observed that the bacteria surrounding the mold was dying off. This was a groundbreaking observation that sparked his curiosity. Fleming conducted numerous experiments to study the mold's effect on bacteria. He named the substance produced by the mold penicillin. This was a game changer, as penicillin had the ability to kill a wide range of bacteria without harming human cells. He published his findings, but that didn't initially gain any attention by his peers. Production also seemed impossible, as it was very difficult to purify the penicillin from the molds.
This discovery of penicillin couldn't have come at a more convenient time. During World War II, infections were a major concern for the soldiers on the battlefield. Because of the close quarters, poor sanitation, and limited medical resources, it was tough to prevent and treat infections for soldiers. Doctors were using sulfonamides to treat patients. Sulfonamides were a group of medicines introduced in the 1930s. However, they caused digestive issues and allergic reactions that are detrimental, and bacteria became very resistant to it quickly. Options for treating infections were extremely slim. So, when penicillin was introduced, the public reacted by calling it a miracle. People wanted it for everyday use.
Penicillin played a vital role in saving countless lives during the war. It was the first effective treatment for bacterial infections and revolutionized battlefield medicine. Infectious diseases that are now easily curable were once deadly. Hospitals were filled with people who had blood poisoning from small cuts, and there were no working treatments for diseases such as pneumonia, rheumatic fever, tuberculosis, gonorrhea, and more. Doctors were left to just sit and wait for a cure. A decade after Fleming's initial discovery, its true potential was realized by scientists Howard Florey from Adelaide, South Australia, and Ernst Chain from Berlin, Germany. They picked up where Fleming had left off and confirmed his findings. They believed in the power of penicillin and worked tirelessly to harness its benefits with the help of Fleming. The challenge now was to find a way to produce penicillin on a large scale. Scientists were working tirelessly to develop methods for mass production, leading to the availability of this life-saving drug for millions of people.
However, there are many arguments and diverse opinions, making production even harder. Eventually, after a very slow and inefficient process, Chain and Florey figured out how to purify the penicillin. Enough was produced that they could begin testing on animals. 8 mice were used in testing, and the 4 given penicillin were the only that survived. However, production was still extremely limited. 6 women, known as the Penicillin Girls, were in charge of fermenting and saving as many precious milligrams of penicillin. The women played a vital role in mass production. Their dedication helped save countless lives by ensuring a steady supply of the life-saving antibiotic.
Human trials began in February of 1941, and production issues became even more evident. 80% of penicillin taken during trials was extracted through urine. Scientists figured out a way to filter and purify the penicillin from the urine. This method allowed scientists to reuse the penicillin and maximize its effectiveness. However, there was still limited availability of the drug, which made it extremely challenging to conduct large-scale trials. The first person to be treated was an Oxford policeman named Albert Alexander. He scratched his face on a rose bush, and the wound became infected. His condition improved drastically within 24 hours of taking penicillin, but supply ran out and he could not be fully treated. He died several weeks later.
The research for penicillin eventually shifted from Britain to the United States during World War II. This change occurred because the United States recognized the potential of penicillin as a life-saving antibiotic and wanted to mass produce it to treat wounded soldiers. The U.S. government invested heavily in research and production, and a team was set up in Peoria, Illinois in the Department of Agriculture to come up with an efficient way to purify the mold from the penicillin. Eventually, pharmaceutical companies, with the support of the government, optimized the fermentation process by using large-scale fermentation tanks to cultivate the mold. This allowed for the production of larger quantities of the antibiotic. The development of efficient extraction and purification played a crucial role in mass production. Penicillin was officially released to the public in 1943. When it was originally released, it was priced about $20 per dose, which is equivalent to around $300 today.
The combined efforts of the scientists in Britain, such as Alexander Fleming, Howard Florey, and Ernst Chain, along with organizations in the U.S., helped make penicillin widely available and revolutionize treatment of bacterial infections. The public was incredibly relieved and hopeful after penicillin was released. It was seen as a medical breakthrough and a game-changer in the fight against bacterial infections. Military personnel had priority access when it was released, but eventually anybody who had a doctor's prescription could take the drug. People saw it as a miracle. Doctors began prescribing it to patients, leading to improved medical outcomes. The availability improved the overall well-being of those serving in the military, allowing them to recover more quickly from infections and return to duty. Bacterial infections went from being one of the leading causes of death to significantly lower rates post-penicillin. It was truly a medical breakthrough that made a difference in the lives of many. After the origination of penicillin, Alexander Fleming continued his research in the fields of antibiotics. He received numerous honors and awards for his contribution to medicine. He remained active in his career until his passing in 1955. Ernst Chain, Howard Florey, and Fleming shared the Nobel Prize in Sociology or Medicine in 1945 for their contributions. Their discovery continues to have a long-lasting impact. We interviewed Kevin Brown, Trust Archivist and Alexander Fleming Museum Curator. He explained to us Alexander Fleming's legacy in the medical field. What do you think Alexander Fleming's legacy is today in the field of medicine, and how is he remembered?
I think his legacy is very much one of having discovered the world's first antibiotic. And also he became associated with it. So he was made a hero of the world. And he was invited all over the world to receive honours. And I think that was partly because he was the human face of medicine and science.
Like Mr. Brown says, the invention of this life-saving drug marked a major milestone in the field of medicine. It sparked a new era of antibiotic research and development. Tetracycline, amoxicillin, and erythromycin are all antibiotics released years after penicillin that help treat a diverse range of bacterial infections. The cost of penicillin has decreased significantly, and it was priced around $15 in today's economy. The invention continues to play a crucial role in modern healthcare, and it is very accessible. However, there is a growing concern about antibiotic resistance. When antibiotics are overused, the body has the ability to resist the drug, making it less effective. Scientists are definitely concerned about it because it can make it harder to treat bacterial infections in the future. It is important to use antibiotics responsibly to prevent further development of antibiotic resistance. Penicillin is also known to cause problems in the GI tract and can throw off the balance of good bacteria in your gut. It can also cause some negative side effects. Some patients prefer to not take antibiotics in order to protect their immune system and not intentionally harm healthy cells in one's body. In addition, overprescription can be dangerous and bad for the body, so it's important to take penicillin responsibly and consult with a physician. Only prescribing antibiotics when necessary ensures that they remain effective in the future.
The innovation of penicillin was a major turning point in history. It revolutionized medicine by saving millions of lives, introducing medical advancements, and by changing the way people act towards disease control. Penicillin truly was a miracle molecule.